Okay, so hold up. From the title on the board, we're gonna cover. So we're gonna cover 3D space. Now, because we know vectors, just a little bit about vectors. We know a lot about vectors, but we're gonna still know two important things, and then we can move on forever. And there's two operations on vectors that we haven't covered yet. So we covered addition, subtraction. And what about multiplication? Well, there isn't a multiplication for vectors really, but we do have something called the dot product and the cross product, and those will be taught. Those will be mentioned in the next video. But today we're just going to get used to our three-dimensional coordinate system. So we have space now. So imagine, I'm going to draw this real quick. So imagine a plane. So this is a line. I'm going to draw a plane. And it's going to look like this. Hopefully you can see that. Now, if you can't see this plane good, I'll just draw it on the side and show you what I mean. So this plane, it kind of looks like this right here. And it's supposed to be laying flat on the ground, but because we have to draw it where we can see all three dimensions, I'm going to draw it like that. So imagine this is a little piece of paper just settled down. So this flat piece of paper is on the ground like that. Kind of. It's just resting flat like that. And these are the axes. And this is the XY plane. So, and we have Y here. Now, it's hard to get used to Y being on the horizontal now. But remember, this isn't really a horizontal. This is just a plane that's flat. We're just representing it as a weird thing. Just imagine this X just popping out at you, kind of. If it's hard, then just look at that. Now, it's going to be easier as soon as I add the third dimension. So this is the x-axis. So this is the y, and this is the x-axis. So the x-axis is the one that's pointing at you this way, and the y. So the x-axis is like right there, y-axis like this. And then we're going to add the last axis, which, if I can actually do this right. This is the z-axis. And this axis is vertical. And if you can see the 3D already, that's great. It's great that you can see the 3-dimension. But if not, I'm going to use our little plane example. And I'm going to put a line through it up. And that will be our z-axis. So visualize. It's very important to visualize this as a 3-dimensional axis. If you can't visualize it no matter what, then I'll just list down a 3D graphing software. It's free and it's just online. Anyway, so if we just make a hole through, and we just go through, that'll be our z-axis. So just imagine this plane, the x and y axis as a plane that's just laying flat like that, and the z-axis just cutting through it. If you can see that, then that's good. But this is a visual helper of what this is supposed to be looking like. And this is the XY plane. So these are I'm gonna know all the positive and negatives of this. So the positives are here. So this is the positive y-axis. Negative y-axis. Positive x-axis. And these lines might help you see the thing. Negative x-axis. Positive z-axis. And then negative z-axis. So that's all the positive and negative values we have up here. And it's hard to visualize right now if I show you this, but we have quadrants, right? In the plane, 4 quadrants, but we have 8 octants in the 3rd dimension. And it goes like 1, 2, 3, 4, 5, 6, 7, 6, 7, 8. And that's difficult to visualize. But again, this site right here, I keep forgetting the name for this, but I'll just put it at the very end of the video. But okay, I'm wasting time right now. So we have, let's put a random point in space. So then we have a random point. Let's call this point P. And let's define it. You know how we have x comma y? Well, now we're going to have x comma y comma z. And this is our, you know how we call it an ordered pair? Well, this is an ordered triple. And if we have another point right over here, let's call this point Q. And this is just x sub 1 comma y sub 1 comma z sub 1. This is our other ordered triple. So we get ordered pairs in the plane. We get ordered triples in the 3D coordinate system. Okay. But there's some formulas that we have to get. So remember how we have a distance and a midpoint formula for 2D in a plane? Well, now we're going to get the 3D distance formula and the 3D midpoint formula. After I give you the the distance formula, it's going to be way easier to get the midpoint formula. So let's do this. So if we connect these lines, these points, and we want to find the distance d, well, remember in the 2D, the 2-dimension, the distance formula is x minus x sub 1 squared plus y minus y1 squared. Oh, right there. Well, now the 3D adds one more z minus z sub 1 squared. That's our distance formula for 3 dimensions. That doesn't look so good. I gotta write that better. Y minus y sub 1 squared plus z minus z sub 1 squared. There you go. Our midpoint formula. Now what does the midpoint formula give us? Give us the averages of all the values, right? The averages. So the midpoint is right here. This midpoint M. So the averages, well, that's just x plus x1 over 2, comma y minus y1 over 2. And that's our midpoint for our plane. But for 3D, we add the z, so that's a plus, z plus z sub 1 over 2. And that's our midpoint formula. And these are very useful formulas to define segments and the distance of segments, the midway of segments in a 3D plane. It's very important to understand. And then we have, so we got our distance formula, we got our midpoint formula. Now we need something else. And I'm going to erase this for a sec, all of this. So in calculus, usually in the first unit, there's a pre-unit that covers lines, distances, and midpoints. It also covers circles. And that's what we're going to do here. It's kind of like a pre-unit for the multivariable calculus. Well, if we have what's a 3D circle? Well, that's a sphere. So if I had that's a bad thing right here. Okay. If I had a sphere with center point, whatever you want the center point to be, and radius r. So remember how we used to solve for circles. I'll do the circle one first. So if we have a circle with radius r, the circle is defined where the distance between the center point and the point here, which is x, comma y, you can say this is h, comma k, and the distance between these 2 points always stays the same, and that's how we kind of define the circle using the distance formula. So instead of d, I write r because they're the same. So r equals the square root of x minus h squared plus y minus k squared. And then we kind of solve for all. We square both sides, and we are left off with that. And that is the formula of the circle. Now with the sphere, the same thing is happening. All the distances in my sphere between this point, x, comma, y, comma, z, and this point, x sub 1, comma, y sub 1, comma, z sub 1, they're all the same. The distances between those points are all the same. So we define them, and remember r is the distance, and is defined as x minus x sub 1 squared plus y minus y sub 1 squared plus z minus z sub 1 squared. And it's all square rooted. We square both sides, we get r squared equals x minus x sub 1 squared plus y minus y1 squared plus z minus z sub 1 squared. And that is the equation of a sphere. So this is the equation of the sphere centered at this point with radius r. Okay, so that's the equation of a sphere. And that's kind of it. That's all it that we learned in this section. 3D space. The video isn't that long, but I just want to show you. There is some problems that will be given. Okay, so now that we know about circles and we're given segments, and we can find the distances, we can find the midpoints, we know how points are defined, well, now we're ready for three-dimensional vectors. Now, before I give you that, in some problems it will tell you to, based on the equation, find the center and the radius of your sphere, and this will all be expanded and just gibberish. Your whole job is to complete the square of all your x's and y's and z's, and then that will give you the squares. And then you can simplify and divide out by all your coefficients or your constants multiplied. And that'll give you your r squared. So that's the way you do that. I'll give you an example if I finish. Three-dimensional vector. So if we have an x, y, z, 3D space, right? And I give you a vector. This vector is not straight, that's all I can tell. But okay, so we have a 3D vector, and we can define this as the x component, comma y component, comma z component. Or we can use the ij form, but instead of having, well actually, everything's the same except the z component, and that's replaced. You add a k, so it's the ijk. So now we have the 3D vector. Everything stays the same with operations, with all the stuff you can do with a vector. All of that stays the same. Now we're ready to do an example. On the circle. Okay, so let's do this. -268. We're given x squared plus y squared plus z squared minus 2x plus 6y plus 8z plus 1 equals 0. And we're trying to figure out the radius and the center of my sphere. And this is the equation of the sphere. Now, one thing I'll tell you is we need to put it in the form. And the way we do that is we complete the square. So let's gather all our x terms and our y terms together so that we can visually see this happen. Okay. So I left little spaces. Will be plus signs. So if we find the missing link, I guess, if we complete the square, this value is going to be 4. No, it's going to be 1. Sorry. Okay. What about this one? This will be 9. And this value is 16, I believe. And now we can complete the square and write this as x minus 1 squared plus y plus 3 squared plus z plus 4 squared plus 1 equals 0. And now we have our form. But if we're adding 1 and 9 and 16, we're going to have to add it to the other side. And we can subtract our 1, and that will just give us 0. This will cancel out. So we get x minus 1 squared plus y plus 3 squared plus z plus 4 squared equals what? 25, which is 5 squared. Wait, we know everything now. We can say that the radius is 5 and the center point is at 1 comma negative 3 comma negative 4. And that's how you do one of these problems. They're not that difficult. is you gotta complete the square. And that's all I got for you. I'm gonna cut. And I'll give you some problems to work with. And that'll be right now. Okay, so I've got to give you one more little information. If we're given a three-dimensional vector, the magnitude of the vector is vx squared, the vy squared plus vz squared. That's the magnitude of your 3D vector right here. Kind of same concept as the distance. But here are your three problems. Number one says find the distance between point A and point B, and it has an arrow. It shows you, well, we're using this point A and this point B. Number two, find the midpoint of the segment AB, where A is this and B is that. Number three, given this little equation, find the radius in the center of the sphere. 4, it's giving you two vectors, and you're supposed to find A, the magnitude of vector V, B, the sum of V and W, C, the difference of V and W, D, 2V plus 3W. So it's just vector operations. Nothing too crazy. And there you go. In the next video, I'll be talking about the two different operations you can do on vectors.